biologists, Mr. Fott here. Today we are going to be going over Chapter 5, the structure and function of large biological molecules. First up, as usual, is the must-know. Today we're going to be talking about dehydration synthesis, specifically in the formation of or organic compounds. We'll also be talking about hydrolysis in the digestion of those same organic compounds. So, just to recap on where we stand with organic compounds, we want to first understand monomers into polymers into our macromolecules. To put things into perspective, our monomers, mono meaning one, mer referring to unit or individual building blocks. These are the small individual pieces, such as in the example down below, an amino acid. When we take a bunch of these and we start to build them together or build them from smaller to larger, now kind of this middle ground, we have polymers. Poly meaning many, mer again referring to units. Now we have multiple units are now strung together. We now have a polymer. We could start to build peptides, in this case when we're talking about amino acids building up to proteins, and then we get into a little bit longer of a chain. Now we get to polypeptides, many peptide bonds. Finally, we get to our giant molecules, and these are typically composed of thousands, if not tens to hundreds of thousands of units. So we're definitely well beyond these small individual monomers, or even kind of the in-between polymer phase. We're at the macro level. This is large. Again, thousands to tens to possibly even hundreds of thousands of units are going to create these much larger structures referred to as macromolecules. In this example, now we have proteins. So this would be the line of progression from the most simple unit, the monomer, all the way up to a macromolecule. So how we do this is we can do one of two things. Either we can build things up, like in the previous example, or we can break things down. So in the creation of these, we use our dehydration synthesis. So dehydration, if we were to break this down, again, into root word and things, to hydrate or hydrate, hydro is the root word here referring to water, and to dehydro, de referring to not, or in this case, a negative connotation. So it is a removal of water is what we're doing. Synthesis is one of those chemical reactions you again may recall from standard chemistry that it means to make or to create something. So when you synthesize, you are making something. And in this case, we are using or the removing of water to create something. This is sometimes also known as a condensation reaction. And think about what condensation is. Like, for instance, if you have a cold glass of water that you pulled from the fridge or something, or like a water bottle, set it on the counter, now it's moving into a much warmer environment. That water that's in the surrounding area around the container is now condensing or moving from a gaseous into a liquid phase. So you are producing water is what you're doing in the liquid state. And if you look down below where we have our red blocks on the left side and then our one red block on the right, we can see there's also plus water. Water is a byproduct. Don't forget, products on the right, reactants on the left when talking about chemical reactions. So we're going to have some water left over. So it's a bit misconstrued here. We're saying we're dehydrating something, but think about what we're dehydrating. In this case, we're actually removing water from the initial reactants. So when trying to create these polymers or even all the way up to macromolecules, we need to remove water from the system. Whereas if we go from the other side, if we were to break things down, notice how the equation is then flipped. And we're leaving red boxes to be vague, but we'll get more specific as we go through. This hydrolysis is the splitting apart, again, water, meaning hydro in this case, to lyse or lysis means to split or to break apart. So we're going to break things down using water. So notice how it's going to be reversed, in which we have water is now in the reactant side, and we need to add it into the equation so that we can break it down. So this would be actually kind of looks like a decomposition reaction, again, if we're relating it back to standard chemistry. But what we're doing here is we are lysing, we're splitting things apart using water, which is why it's referred to as hydrolysis. So here's a few examples, again, a little more specific. So let's say we want to do dehydration reaction. So we're going to synthesize a polymer. We're going to make this chain a little bit longer. Each one of those purple spheres, and in the realm of AP Bio, purple spheres are going to represent amino acids or ultimately our protein structures when we get there. But we have these polymers, we have a few of these amino acid structures are linked together. we want to add in another one. So notice how we take one hydrogen plus the HO, two H's, one O. Now you have then produced water. We remove the water. We are dehydrating it so that we can then link them together to make a larger or longer polymer in this case. If we wanted to do the opposite, if we wanted to split it apart or hydrolysis, we would then add in water. So again, notice down below, we are adding water in. The arrow is moving into an inward direction from reactants to products. That's the top moving to the bottom, in which you then reintroduce the one hydrogen on the left and the HO, the remaining portion of it, on the right to split our polymer apart or to break it down. Here's a few more examples we'll look at. So if we have something more specific, again, this happens to be about proteins. These are great examples, or about our carbohydrates down below. So we see at the top here is a dehydration synthesis. So it's highlighting the HO, or the OH in this case. That's our hydroxide functional group. And our hydrogen, we now remove the water as indicated in the product side. We can see the H2O. Notice how the newly formed bond is a formal bond. This is a covalent bond between the carbon and nitrogen. This is referred to as a peptide bond, as we're then producing our proteins. Down below, if we wanted to again do another dehydration synthesis, take two individual monosaccharides, single sugars, and we wanted to make a disaccharide, di referring to two, saccharides referring to sugar. We need to once again highlight the OH, the hydroxide, as well as the hydrogen to remove them. We have two hydrogens and one oxygen, thus creating a water molecule is being removed, or we're dehydrating it. Eventually, if this process continues, you can create a polysaccharide. Oppositely, if we were to add water in, so notice how we're going to take a disaccharide on the left, that's the maltose. We know that this is a saccharide, OSE, ose is going to be the ending for all sugars. We add in some water, and it, not automatically or magically here, it's going to undergo a chemical reaction series in which will ultimately split apart this disaccharide into two individual monosaccharides. Thanks for watching. Let me know if you have any more questions.